some of the faces they're very familiar. As an organization, we want to change the form because having a charge event means that less people will come, and also Cyberport. Some people never go to Cyberport. Okay, it's too far. Okay, so we have a change. So now it's in CTU, and we hope that you enjoy this. But on the other hand, for example, in the schedule it says refreshment, and actually you have to buy your own refreshment. Unfortunately, in Cyberport, yes, there Cyberport actually have some sponsorship. We have better sponsorship because it's a nicer place. So this time we have less sponsorship. I'm the person who in charge of money. So if you want your donation receipt or if you're one of the speakers that have traveled, please find me. I will be in the front. And we don't know yet whether this conference will be a surplus or will it be a loss. So if you think that we're doing a good thing, you can come to the counter at the front and buy a T-shirt and to support our work. Okay, and also for those who cannot come and so on, or if you are a friend that haven't got a ticket, you can tell them that it's we have live streamed on YouTube, but then you say, why am I here? I can just sit at home, why come here so early? So I encourage you all to interact, to talk to the people next to you and talk to the speakers. And then one of the most important thing about the conference is you can meet people. Okay, so why do you have to hear in person? Like we are all have our mobile, we can go to Facebook and so on. But if you are here in person, please talk to other people and talk to our staff and so on. We can all help each other to learn more. Okay, and then may I introduce Sammy Fong, the president of Open Source Hong Kong.
Okay, good morning, everyone. I'm Sammy from Open Source Hong Kong, and who organized PyCon Hong Kong with other volunteers. So I am a developer who writes some web scrapers in Python to collect some data from the internet. Afterward, I organized open source Hong Kong community to promote open source and open data in Hong Kong and Asia, and collect to with other global tech community as well. We organize a monthly meetup, usually in City University, and we also organize a PyCon Hong Kong and annual open source conference as well. So you can find it out on our website opensource.hk, and we hope to we can develop and contribute to the local tech industry. And lastly, I hope you enjoy PyCon this year and share your opinions, ideas, what we can do in the near future for the tech industry and our life. So you can talk with me anywhere in this conference. Yeah, thank you.
係，我想可唔可以播我部機啲嘢出嚟啊？係咪一個困難啊？ 係啦，因為我要講 sponsor。係啦，係啦，咁我哋都有幾個 sponsor 嘅。誒點啊？有冇得齋轉 VGA 啊？唔係 VGA 啊，係呢個先，我睇下係咪我自己未轉咧？可能係。轉出唔到喎。唔得，呢條唔得，唔係呢條啊，嗬！但我又唔想，係咪要掹 speaker 嗰邊？但我又唔想掹喎，點算啊？掹啦，掹啊！你有冇條啱使㗎？
我 capture 喺邊啊？
啊，唔係，簡單呢度啦。
哦，好，
我哋
得嘅。
你用係啦，我唔想搞套嘢啊。
你呢個係咪 C 嚟嘅？定 display 嘅？
咩啊？
睇一睇。
得，唔好意思啊，各位。Visualizer 得唔得？好。
你好似未睇過啊？未得。
都未。
未得。你聽唔到？
聽唔到啊？點解啊？點解㗎？
唔係，但係掹咗條 HDMI 就插。
冇玩啦。
唔係啊。
條 HDMI 啦，冇玩。
唔係啊，頭先 set 咗好耐㗎。Keynote 最重要嘛。set 完係嘛？
我諗佢。
Sorry about that for the technical stuff. So to organize PyCon in different area in the world, actually the Python Software Foundation will give us subsidies, and we are very grateful for that. And next one, and then we have general sponsors. Avalon is so as you can see that they do data analysis and do data-driven solutions, and then do professional development training and so on. Okay, and then the next one is AXA investment managers, and then the next one is MySQL. I don't think I have to introduce MySQL. Many of you are using that database now, right? And also we have patrons, Dick Dung, Henry Law, Greg Griffith, Lawrence Law, Leo Chiu, and Rossetti Huang. So we are very grateful to these organizations and people. Okay, so I think I've talked enough. Yes. So may I introduce the MC, Kara, to introduce our speaker.
Good morning, ladies and gentlemen. Welcome to PyCon Hong Kong 2017. I'm the MC of morning sections. I'm Kara. And let us introduce our first keynote section that brings you by Mr. Denis Makogon. He's a principal software developer in Oracle, focusing on product development along with bringing well-designed and production-ready integration with cloud solutions. He's also a contributor to various open-source projects and cloud-related technologies. Today, his topic is applying serverless architecture pattern to distributed data processing. Serverless architectures refer to applications that significantly depend on cloud devices, as known as Backend as a service, or in custom code that's run in ephemeral runtime. So let us welcome our first speaker, Denis.
Thank you. Probably everyone can hear me without microphone, so I just don't have to stand here, just near one. Okay, cool. So the first, I want to say thank you to PyCon organizers. They brought us all here.
Sorry, the live stream is not capturing.
Okay. Again, I want to say thank you to PyCon organizers this year. They brought us all here. As you know, they just dropped the prices so we can just come here for free and just spend your money on your lunch. So let's just begin. So in our time, we try to build a new products, new solutions to let developers focus on development specifically and to reduce amount of work that is related to DevOps thing. So today I'm going to talk about how you can apply serverless architecture patterns to distributed data processing. So, but before we start, I'd ask you to express your opinion by posting tweets with mentions to Onion Omega 2 account on Twitter. So the one thing I would like to ask you to do is to post a picture with your emotion. This is kind of required. if you don't have Twitter dongle, just enjoy. So we got used to develop bigger apps. Then microservices appeared on our surface, and we thought that it's cool. It's scalable. It's nice to have them separate. They're small. But what's next? You still have to have someone to maintain them, to run them in production. And we decided to go to a new feature of cloud services, which is called serverless. So the serverless doesn't have actually an academic definition of this term, but it means that you can run your code not on your machine, and your code environment scales upon the usage of your services. So as I told you, the serverless would be the next buzzword in cloud infrastructures for a couple of probably decades. So the first one was the Amazon and the Google, and personally I'm talking on open source projects that can you just take and participate in. This is the quote what I've seen in internet, and I kind of think that this is one actually describes and expresses the opinion of the people when they heard about serverless. You still have code, but you still have someone to run it and still someone to maintain the servers. So serverless doesn't mean you don't have servers, but you don't have to actually interact them specifically. At Oracle, we take really serious the development experience. We want to bring the high level. We want to bring the development onto high level. We didn't want the developers to spend a lot of money and powers on maintaining their code in production. We just want to let developers focus. So in Oracle, we treat developers as a first-class citizens for us. So today I'm going to talk about a fan project, which is a serverless product made by developers for developers because we care. Bless you. So what's the fan project? A fan project is an open source, container native, developer oriented, developer friendly, and its runtime for serverless is completely agnostic. So you can run your apps in different languages. So you can combine Java, Python, Go, Ruby, Node, and whatever you would like to pick, and it could run like a single app. So what's the FDKs? It's a function development kit. We in Oracle made a bunch of libraries that help you to work with our serverless platform. They are all free. You can just join and develop. So the first one officially released on the Oracle Open World was, of course, Java, because Oracle is Java. The second one was Python, and we treat Python like our first-class citizen for developing data processing, machine learning languages. And the third one was, of course, Go, because Go is power. Okay. The thing I want to describe you today is how you can actually make your app serverless and how you can apply serverless functions to data processing. So I've specifically for this PyCon, I made an app that uses OpenCV, TensorFlow. It based on Twitter. That's why I ask you to post your emotions on Twitter. And it uses for persistency Postgres. So how this app works, when you submit a tweet with your emotion expression as image, I have a function that takes that image, it recognizes your mental emotion. And based on those emotions, I'm actually trying to figure out, am I good on this talk or you're gonna blame me in the end? So, and then I'm gonna show you the actual statistics of what you people really think. And it's completely anonymous, so don't worry. So this is how it works. When you post, I have a Twitter bot that actually goes to Twitter and asks for specific tweets. I have a function that runs TensorFlow and OpenCV emotion recognition. It used two functions to store and retrieve data from persistency layer. So all of these components are completely serverless except TwitterBot and Postgres. So the beauty of this solution is that you don't have to scale your app and you don't have to scale up and scale down. Everything is being done by the serverless platform. So your app scales as much as you need, as much work you can have on your own queue. So this kind of details. So this kind of details how many resources on RAM and storage you have to run all this app. And the beauty of serverless solution is that you can run all this app on this small chip. It's IO chip called Onion Omega 2. It has only 30 megabytes of storage and 64 megabytes of RAM. So basically, tell me how you can fit there the TensorFlow. It wouldn't fit even just, you can actually download it there. So let's just take a look at how the components work. As I told you, I have a Twitter bot that goes synchronously, asks for tweets, then goes to TensorFlow. I made a deep neural network, so probably most of you are familiar with that because you raised the hand about talking machine learning. Each time you have a new tweet, I have a OpenCV that pulls out the face recognition, which is kind of basic thing that everyone starts with, and uses TensorFlow to actually recognize the emotion by defining the percentage according to specific specific emotions. This was one of the challenges on the Kaggle probably like a year ago. So this is how it looks on the second state after emotion recognition. We have a function that returns JSON objects that looks like a set of main and alternative emotions, because like every emotion has 7 different values, like they're kind of descending. And the other interesting part of serverless that you can actually build even websites with serverless. So you can actually define the function that just returns you an HTML and put it into our FN platform. So why actually serverless matter? Because it scales on demand, just as I told you. As much work you have to do, that much the platform actually scales your environment. You can build sequentials and pipelines. So actually what I have here is a sequential. So I have a bunch of functions that each one calls another by bypassing specific data from this stage to following stage. And all my functions except those who work with database, they're kind of stateless. So this is one of the main things for serverless. So you don't have to, you can just think that your functions are kinda stateful. Every time you get a new function, you get completely new runtime for the language. So you can just submit a new task that contains all necessary information for you, and you're gonna process that. So applying serverless to data processing is quite interesting thing, because all of you probably worked with Apache Spark, or at least seen how it works. So it's based on the MapReduce thing. So just imagine if you have functions that actually do machine learning, data processing, like emotion recognition, and etc. Doesn't look familiar. So we're trying to build a framework for serverless MapReduce. So, and the beauty of this solution is that you don't have to maintain the environment. So you don't have to have a bunch of servers running Apache Spark. So your application would scale for data processing as much as you need, as much data you have here. Yep. So specifically for this PyCon, in Oracle, we developed a new type of serverless Python functions. So we actually, for our Python FDK, we developed a bunch of helpers that can take your actual functions just as you write them on the module and take them to a functions platform. So basically, what it does, it takes your functions, it generates its state, its stack, and then sends them to a function that runs a general purpose Python 3.6 function. So basically, you can serialize your actual code and run it on the cloud. So you probably heard about PyCloud, Cloud Pickle, Dill, Pickle itself, Protocol Pickle. So we treat Python as our main language for data processing, and we're looking forward to develop serverless solutions for Python specifically. This is why we put a lot of powers in developing our FDKs for like what we think main languages that we use in our development. So from version 0.0.3, Python FDK will support running your functions on the event platform, and also it contains about like a couple of more helpers that can actually inject any code execution into your function and let you process the result of the serverless function in Python code. So I think it was kind of fast. So I encourage you to read the articles that I've at least asked before. So just join the Medium, join the PyCon Medium. They post kind of cool stuff. I encourage you to read about the serverless because it's gonna be our nearest future, and this is what we actually have already at this moment. I encourage you to look at the FN project, which is we think that FN project provides you the necessary stuff for your development, because the less power you need to develop and maintain your code, the more you can do. And I encourage you to look at the Omega 2 apps. Those are I have there a bunch of serverless apps that can help you to run that you can run on any IO device using the FN platform. Thank you. Oh yeah, and I've got a bunch of stickers that I've put on entrance, and I also got 2 T-shirts. So if you have questions, you might get one. Okay, thank you. You got a T-shirt.
Thank you for that. Just a quick question. So if the serverless technology is so sort of streamlined and much superior in an architectural way, so why would we go down like a server architecture in the beginning from all things? Like, you know, all the backend and the structure in a, with sort of like a server in mind.
like serverless helps you to reorganize your apps, but you still have to think as you develop the full backend service. So you have to actually define the bunch of APIs that you want to run as your like first citizen functions, and then put them into cloud. But you still have onto any serverless platform. But you still have to have at least one entry point for all those functions. So like in my case, I have a Twitter bot that is an entrance to my serverless app. So basically, this is kind of necessary thing. We can't just go away from like considering not developing backend technologies. We still have to do them, but we have to change the way how we treat backend apps. This is why I call the serverless thing called backend as a service. So you actually can scale out as much as you need, and then just scale down. You're welcome. You got one. Just. Yay. Any more questions? Okay, I got only one T-shirt. Okay, just.
You go first.
Go first.
Thank you. So for the use case, is it more like for me, like I'm a developer, not working for companies, so I can use like that kind of serverless, or is it also for big companies? Because it isn't like big companies got enough money to pay, some backend guys to take care of setting up all the infrastructure.
So, have you used one of the like mainline cloud providers like Amazon, Google? So you know how the bill can go up like fastly. So that's kind of point. Like if you're a small startup that like 10 people probably like with accounting management, so you didn't have a lot of money to go to invest in your cloud infrastructure. So you basically would prefer to go for serverless instead going for regular containers or virtual machines. So it's gonna save your money. For instance, as far as I know, like the same Amazon allows you to do 10,000 queries to a Lambda service for 10 cents probably. So you can just, it's really saves your money, and it helps you to get rid of DevOps thing, because you know how to package, you know what's the runtime, your runtime is reproducible wherever you run it. So like you're the only one who responsible for your own code. I hope I answered your question. I hope I answered your question. Thank you. You're the one. Yeah.
So my question is, because traditionally I've never touched any serverless architecture. So traditionally I would, let's say, develop a web app, right? I would use Django and serve it with WSGI and Apache, let's say. Sometimes the problem is that Apache likes to kill off idle instances of its child processes, and then when it spins that up again, there's the warm-up time. So what happens about that with a serverless architecture? Because in serverless architecture, you also scale in, right, when it's idle. But what happens when you need to scale it again? What happens to warm-up time?
So in the Event project, we actually solved this problem. So we defined two different modes for your functions. We called cold and hot. So basically, cold function takes you 300 milliseconds to start, then run your code as long as it actually takes. So it's up to you. You can actually test this. As I told you, that your environment and your code is reproducible wherever you run it. So we have a hot mode. Hot mode makes function live as long as you have tasks, and it has an idle timeout. So between the requests, for instance, you have one request and then just nothing. Function lives for a certain period of time that you actually can define through a fan API. So it can just handle as much as you want. and it will just scale down whenever your tasks are finished and there's nothing much to do for. So this one is kind of fast because we made it completely concurrent. So the event project itself is written in Go, so it's very fast. So from event side, it's completely concurrent requests. From the function side, they are also concurrent based on the FDKs that we developed. So this kind of fast. So, and for this particular moment in event, we support two different protocols for functions. So one is the HTTP when you receive an HTTP request, raw HTTP request through std-in, but not for like TCP or whatever. And you can receive in JSON objects. But you have to be aware that every request gives you a streaming object. So it can be big, it can be small. You have to treat it with respect. So it can be really big. So, thank you. So, and as I told you, I want to show you what we have. So this is not actually a running web server. It's a function. So we can just try to and see what we have more. So as you can see, we have an FN platform running here. So you got some logs out here appearing. So I hope I was at least not bad. Let me just find this. So, at least two people are happy and one angry. Probably the one who is angry wants a t-shirt. Sorry. Whoever you are, I got only two, but you have stickers out there. Thank you.
Thank you, Dennis, for his wonderful talk and inspirations. And we are now going to take a group photo. May we gather to the center of audiences so that other staffs can join in the photo. Yes, please gather to the center. May guests on the left-hand side go to the center, please.